Let me now hand it over to our next speaker, Daryl Cherry from Clearwater Analytics. Daryl has been a leading innovator in space. It's about 19 US patents to his name. He's been doing this for last 25 years, and you'll love to hear from him as he talks about Gen AI and how Gen AI intersects with data.
Okay, thanks, Avinash. So I'm Daryl Cherry, distinguished engineer at Clearwater Analytics. I've been at Clearwater for a little over 4 years now, but been in the industry for over 25 years. I'm in the CTO office, and so I lead our generative AI strategy and technology, as well as enterprise architecture for Clearwater. And for those who aren't familiar with Clearwater Analytics, we're a public fintech SaaS company that does investment management and accounting. We report and aggregate and reconcile over $7.3 trillion in assets under management. Our reconciliation is over 90% fully automated. And we have 13,000 plus users on our multi-tenant SaaS system. Our net promoter score is north of 60, so our clients really love our products and services, and we love our clients. It's what drives us, and it's our passion. So with that, let's talk about generative AI. So this is a press release that Clearwater did recently, about 3 or 4 weeks ago, announcing our Clearwater Intelligent Console. So this is what we're calling Quick, and we have a Quick family of products for the different products that Clearwater offers, and it integrates generative AI solutions into those various products. So with Quick, we really have three effective capabilities that it can do. The first one is knowledge awareness. And so it understands what Clearwater does, it understands how Clearwater operates and does accounting, and all the different things that our customers are calling to ask questions about. Quick will know the answers. And so they can use Quick, get the answers very fast, very quickly, and be able to be on their way to do their business. And they don't have to wait for customer support or long times in exchanging emails. So that's one of the big pillars of our initial Quick release. The second is our application awareness. So the application awareness is where Quick understands the application that our user is operating in. So if they're looking at different reports and they're trying to find something, they can ask Quick where this particular report is. If they want to say something like, what's my exposure to Germany? They can ask that to Quick. Quick will look what reports are available, and it can show them a link where they can click. They'll say, this is your international exposure report. And then I'll give them the list of different exposures worldwide. The third element with Quick that we're looking at is, and this is one that is under development currently, is data awareness. And so in this particular pillar for Quick, this understands not only the application the user is in, but also their data and how their data is being presented in the report, how it's being used. And so now, besides asking questions about Clearwater in general and the applications and the accounting or the applications and reports, they can now ask questions about their data and get answers for how was something calculated, how does the book yield tie out, those types of questions that rely on the data underneath to answer what the customer needs. So this is a high level of our platform. And this is really what we're at now in terms of a generative AI system. But it's important to rewind back to the beginning. And so the beginning was about a year ago when our CEO got a core group of us together and asked us to look at generative AI and how we can drive that into our business and our solutions and our products. So that core group, we had three work streams that we were running on. We said, okay, the first thing is let's do an ideathon in the company. Let's find out from our domain experts, our subject matter experts, what are the biggest problems they're facing and how do they think generative AI could help them build solutions. And with the ideathon, it gave us, I think we had over 300 ideas. And we narrowed it down to about 10 that we thought were the really high value ones we should pursue. In parallel, we started building an organization around this. So we started getting lots of different folks, interviewing, building out a generative AI organization in Clearwater that'll look at implementing those different solutions that came out of the ideathon. And the third was creating a ChatGPT clone. So Clearwater, like many companies out there, when ChatGPT was announced, CISOs around the world lost their minds because different companies were putting sensitive data. Employees would put data in ChatGPT, and that point it's in public domain. So we had our InfoSec came out and said, "Thou shalt not use ChatGPT for any company data." So that was one useful tool that seemed really promising. That now the company didn't have at their disposal. So we wanted to create a clone for that, something that was private, that was secure, that all of our teams could use and use for their business and get the advantages of the efficiency gains ChatGPT could provide them. And so we released the first version of that in about 3 weeks, and our teams started using it, customer service operations, and found extreme value in it. It was using the same GPT models that ChatGPT was using through Azure. And so that led us down this journey and this path of building this platform. So we called that tool Crystal internally. And Crystal was a full tool with this platform included. But as we evolved it, we pulled it out, created this horizontal platform that we could build other solutions on top of. And Crystal remained as a vertical solution for our internal teams. Quick then was developed as an external tool on this platform for our customers. And that's how this came to be. As you can look at the bottom of this, vector databases and retrieval augmented generation really powers this system. And we have internal tools where we have LangChain and other things where we can access data inside of Clearwater. And of course, the prompts are a key element to this as well. We have system prompts that really guide what the users can do and how they can operate. We have prompt templates that help our systems and our teams like operations and customer support do repeated processes and just put the data in. And then the user prompts. So anybody that's using the system, be it an internal person or customer, all that comes into the system. We use our RAG databases and our tools and then pass all that information to the LLM to get the right response for our customer or for our internal teams. And I'll go into some detail here around these different components of our platform. So the first area, retrieval augmented generation, like I said, this is a very fundamental part of our platform. And this is really making LLMs even smarter. So they're already pretty smart. LLMs, if you looked at GPT-4, it's passed the LSAT, it's passed the GRE exam. So it's pretty smart, but there's things that it doesn't know. So before we talk about some of those different things, let's look at the mechanics of what RAG does. So with the vector database, everything, even though it's large language models and you can have it write poetry for you, you can do essays. At the end of the day, it's all math and it's all vectors. And so what we do is we take a knowledge base, some source of information that we want to add to that large language model's knowledge, and we vectorize it, we embed it. And that puts all these different math vectors, transforms that text into math vectors, puts it all in this database. And then when somebody's prompting our system, we take that prompt, we embed that into vectors, and we do a query against this vector database with the prompt vectors. That pulls out a bunch of semantic similar searches, things like approximate nearest neighbor or algorithms that are used to pull related information. And we pass all of that information into the large language model. And it uses that to go and understand what the context is and what we're asking and provide us a solution. So here's a real example in Clearwater of how we use RAG. So in Clearwater, we like to name our systems after Greek mythology. So we have a system called Helios. Now, it's Greek mythology, so large language models, they know that, they understand it. So when I ask a question, what is Helios? It tells me, oh, it's the personification of the sun god in Greek mythology. It's depicted as handsome, so on and so forth, and gives us all the information about Helios and what it means in Greek mythology. Now, in Clearwater, Helios means something different. So when we take our knowledge bases and our RAG systems and we enable that, now we ask it the same question, what is Helios? And it tells us Helios is an internal data reconciliation tool used by Clearwater Analytics. And it gives us all the information for what Helios is and does and how it's used. One other key element here in RAG are the citations. So this gives us explainability. Now we see all the different links to where it got this data from. So not only are we seeing the answer to our question, but we now see the sources that were used to develop that answer with the LLM. So it lets the user go back and they can search and make sure that these things are accurate, and it gives them confidence in using these different responses that the LLM gives us in our system. So this is a high level or advanced RAG system. Now we took that, let's supercharge this to say, let's RAG things on the fly. So now this gives us the ability to take a document, a large document, medium document, whatever, upload it into our system, and our system will vectorize that document, store it in the database, and now we can ask questions about that document. We can ask it to do summarizations, we can extract data from it, lots of information now that we can use with a document that we didn't want to read or didn't have time to digest, or we wanted to use it as a knowledge source to ask various questions. So just like the RAG system, as we prompt it, that goes into the embeddings and the vector database query. We get information from that document. It goes into the LLM and generates that response. And we've used this quite successfully. So here's an example of what we've done in Clearwater with that document advanced RAG system. So we have different policies that come. These are investment policies from various customers. They're documents. They give all the kinds of constraints that that company uses to invest their money, and what kind of stocks, what kind of assets, those types of things. And so we uploaded this document, and I highlighted a few areas here. We can ask questions now. So I uploaded it and asked a question, what's the maximum investment in a single preferred stock? And it comes back, says it's no more than 3% of total admitted assets. Ask another question, what kind of fixed income securities can I invest in? And it comes back from the document, you can invest in NAIC Class 1 or Class 2. And ask another third question, how much cash should I include in my portfolio? According to the document, you should have at least $500,000 in cash and cash equivalents so that you can have sufficient liquidity. So it pulls all this information from the document. It can answer any questions that we have. So the next one's around tooling. So as we saw in that overall document, we had tools that were also on top of the platform. So we have the knowledge bases underneath, we have the tooling on top. And this is really about making LLMs more capable. So they can do lots of things, but there's some things they can't do very well. So now you can introduce tools to fill those different gaps where the LLM can't do certain things. So in this example that I'll show here, we created a search tool and a date calculator tool. It's a contrived example, but it's kind of fun. The title and description are very key. So if you're using LangChain or a tooling foundation platform, you can now provide the description in very good detail so the LLM can understand which tool it should use based on the question and the prompt that the user is asking. So in here we have, like I said, a search tool, a date calculator tool, shows the schema that the LLM needs to communicate with that tool and how it should get the data in response. So here, this little example, we have the user ask a question, how long was the latest Matrix movie released after the original? So the search tool is going to go out and says, I need to use that tool to get back the release dates. So it uses the tool, gets back March 31st, 1999 for the Matrix and December 22nd, 2021 for Resurrections, which is the last one. And now it uses the date calculator tool because it has two dates. It needs to know the difference. Let's talk to the date calculator tool and give it those two dates. Then we get back 22 years, 8 months, and 23 days. That lets the LLM now take all that information, formulate a proper response that says the Matrix Resurrections was released on 12/22/21, which is 22 years, 8 months, and 23 days after the original Matrix movie was released on 3/31/1999. So just an example of how the LLM can understand the question being asked, understand what tools it should use to get answers to those questions, and then provide a really good response. So this is a real example in Clearwater of what we've done with LangChain and using tooling. So we have a tool that we've developed called Available Reports. And if you recall what I mentioned with the query for what's my exposure to Germany, that was an example of using this Available Reports tool. So here we can ask it a question while we're in the application. We say, what's my cash balance by position? And so what that does is it knows that we have a number of reports and it can look through those reports and say which reports match that question that's being asked. And it finds two, gap balance sheet by position and stat balance by position. And so it now gives us links. And so we can navigate in the application directly by just clicking those links that the LM has responded in quick with. And that is effectively a way for us to take novice users of our system who don't know the ins and outs of everything. They can ask questions and navigate just like a power user. So this has been a really big advantage for our customers, and they've given us wonderful feedback about it. Okay, so fine tuning is another thing that we're looking at. This is really making LLMs more specialized. And so here, models come in many sizes, right? You have GPT-4, which is a very large model, trillions of parameters. And then you have smaller models like the 7B Mistral, Llama 7B, other ones that are smaller and they're cheaper. So the GPT-4 models, like we said, they're very smart. They can pass the LSAT. But do you need a model that can build poetry for you and do all these things, or do you need a model that can just run your tasks and do what you need to do? So this is where the option will be something that you need to decide based on your use cases that you have to solve. So one model to rule them all, that gives you the GPT-4 example, very expensive, or smaller specialized ones to the task. So at Clearwater, we started out with the GPT-4 models, the bigger ones, but we're also looking at how do we fine tune and do smaller models, because that's going to be much more cost effective for us as we scale this system with all of our different customers. And we want to have extra specialties like regulatory specialties, accounting specialties. So data is paramount for fine-tuning. So as you do this, and if you go down the fine-tuning path, you really need to curate and have large amounts of data that you can use to do that training. So that's a very important point. Even in RAG systems, you want to make sure that your data is very curated and is clean as you're putting it in your system, because that's what the model is using to answer the questions for your customer. There's two common models used in fine-tuning, prompt and completion pairs, where you have examples of prompts and completions that you use to train the model. And the other one is domain adaptation, where now I can just take different documents and I can add that to the knowledge of that particular large language model. And then use that knowledge that it's learned to answer questions. So productionizing generative AI. So this is another key element here. So as you're building these cool tools and you can do lots of great things, how does that translate into putting something to production that your customers can now use and you can trust with them? So validation and regression testing are key. Just like regular code, you have unit tests you can go through, and it's very deterministic for what you're doing. But when you're using a large language model, I can put the same prompt in and my response can differ every time. Even though it's really meaning the same thing, the exactness of that response is going to be different. So it's not deterministic like a unit test capability. So in here, what we've done in Clearwater is we set up a system where we have a test framework that has known good prompts and known good responses. So now we can run through that known good prompt, get a response, and then have the test framework use another LLM to compare those responses and give us a similarity score based on how we've structured it. And then we get a response of a pass or fail from the test framework. And that's how we know if the system is regressed properly or if there's a problem and something's changed. And we've seen this as we've altered system prompts, where we've changed the system prompt, and that effectively changes the whole prompt going to the LLM, and our response came out different than we expected in a lower quality prompt. So this really helps us make sure that what we're doing, any changes we're making, don't impact adversely our customers or other internal people using the system. Monitoring and alerting is another very key one. You have to, when you're running a production, you need to monitor and alert on the system. If something goes sideways, you want to know right away. And having full audit trails is very key. So every prompt and response that comes into the system, we're logging that. So if something does go awry, we can go back and we can look and see exactly what happened and do a forensic audit to understand where the problem was and go patch it up. So responsible AI, this is a very key element here. As you're doing a new technology, you have to really help customers understand and get on board with this. If you go back, 20 plus years, you remember when cloud was becoming a big thing, customers were very nervous. People were very nervous about putting their data on the cloud and moving to the cloud. They're like, well, what do you mean my things are going to be outside of my control on this other public cloud like Amazon? And so you had to work with customers to make them understand how secure things still were, how protected everything was, all the security in place to ensure what's going on, and get them comfortable doing that move. And the same is true with AI today. So there's a lot of customers, they have the spectrum where some are eager to use it and some are very nervous about what it's doing. Is my prompts being used to train the models? How's my data being protected? So these are some of the pillars we look at responsible AI. Fairness is a big one. We want to be sure we don't reinforce bias, making sure that the data we're using to either fine tune or use in the RAG system is unbiased data. Explainability is another big one because we want to make sure that we can understand what's happening under the covers. As we showed with the RAG example, we have explainability through citations and other ways that we can look at where did this answer come from? What data was used to generate this particular answer? Security is another paramount one. Like I mentioned, we want to make sure that people understand that their system is protected. We have three areas where we use security in the generative AI systems. One is the overall system security. So make sure our VPCs, everything is all protected and locked down. We also have application level security to make sure our applications are protected. We're using data that's encrypted at rest and at transit. And then we have data protection as well. So we want to make sure that as we're using LLMs, we don't let customer A be able to jailbreak the LLM and access customer B's data. So all of the security we placed around that allows customer A can only ever see customer A's data. So the system itself will determine what data the LLM can use. That way the LLM doesn't have any determination and any decision making in which data it's going to pull. And so that keeps that secure. So customer A is protected, customer B is protected, and they're partitioned. And transparency. We want to make sure that we're open how we're doing things. We have a white paper that we give customers. It lets them know how we use AI, how our AI models operate, and the processes that we have in place to make sure these things are protected. And then privacy, like I mentioned. They want to make sure we're not using their data in our models or their prompts in our models. And so we assure them of that. And that goes part of that transparency. We explain how we're using data, what we're doing with it. And it gives the customer confidence to know that their privacy is paramount with us. So now if we take a step back, we look at just our overall tech stack. So outside of just generative AI, Clearwater, as I mentioned at the beginning, we do a lot of things. We aggregate, we reconcile, and we report on all the data that we have in our system and all the $7.3 trillion of assets under management that we have. So Nexla as part of this is really the ingestion side of it for us. So we use them with lots of different connectors. We can connect lots of data sources. We can pull in lots of different data formats. We ingest all that data into our system. And we go through the Clearwater processes of normalizing it and enriching it with all of Clearwater's information and Clearwater's data. Then we process and calculate it. We're doing lots of accounting and aggregation and other calculations on that data. and then we store that off and build it for reports for our customers. So statements, reports, and other things that they can use in their accounting and in their business.